Let's solve binomial expansions using the binomial theorem. Now, without wasting much of the time, let's start. Okay, so according to the binomial theorem, if you've got an expression, let's say a plus x, this is raised to the power n. So your formula therefore for the binomial theorem, it is a to the power n. N is just the power, plus you're going to have n, choose 1, then you're going to have a, n minus 1, then you're going to have x, this is x to the power 1, okay, plus you're going to go to the third term, n, choose 2, then you're going to write your a now to be n minus 2, then you're going to have x. Now the power of x now is going to increase, so it will be x squared, okay, plus then you come to the other one, or let me say it goes on until you are going to reach to the last one. The last one is supposed to be n, x to the power n, okay. So that is the binomial theorem. Let's solve an example. Let's say you have the binomial theorem. Let's say they've asked you to solve using the binomial theorem. You have got 2 plus x to the power 5, okay. So how are you going to solve this? So you are going to have your 2 plus x to the power 5 to be equals to, if you are using the binomial theorem, a is the first term, right? So even in this case 2 will be our first term, so I'm going to write my 2. Now this 2 is raised to the power n. N in this case, it is the power, okay. So what is the power in our case? The power, it is 5, so I'm going to say 2 to the power 5, okay, plus then the power is 5, which is our n, so I'm going to have 5, okay. So this is also, so this will be 5, choose 1, then we're going to have a in this case is 2, it will be to the power n minus 1, so that would be n in this case, it is 5 minus a 1, okay. This is multiplying by x. Now like that, we come to the second term, or let me say the third term. In this case you have 5. Now in this case we are going to the third term, it will be 2, okay. Then you're going to have your 2, now the power minus 2, okay. This is multiplying by x squared, okay. Let's reach to maybe 5. Let's say now you're going to have 5, choose 2, okay. Now you're going to have 2 to the power, so now to be 5, this will be 3 now, okay, this will be 3, so now you're going to have 5 minus 3, then you're going to have x to the power 3, okay. Then we can also write the other one. Allow me to write it here, plus now you're going to have 5, choose 4, you're going to have 2, then you're going to have 5 minus 4, then you get your multiplied by x to the power 4 in this case, plus the last one, let's say it will be x to the power 5, okay. So now how do we solve such an expression, okay? Now before we start solving this one, I have to mention something very important: combinations. So if you've got n and r, so this is called a combination. Okay, so now how do we solve combination? So n choose r, or n combination r, is equivalent to, you're going to write your n combination r, this will be equals to n factorial over n minus r factorial, then you're going to have r factorial. Now what is a factorial? If I say let me say, if I say 5 factorial, what 5 factorial implies is that you're going to multiply 5, and you're going to be going to the smallest numbers. So that would be 5 times 4 times 3 times 2 times 1. That's what 5 factorial means. Therefore, our 4 factorial also mean 4 factorial will be 4 multiplied by 3 multiplied by 2 multiplied by 1. Our 3 factorial will just be 3 multiplied by 2 multiplied by 1. 2 factorial will just be 2 multiplied by 1. 1 factorial, it will just be 1 times 1, which is just 1. So this is how you solve combinations. Okay, now you are using that formula that we've put. Okay, so let's give an example, or let's solve using the question that we have. Okay, so let me just solve these ones in advance. Okay, so the first one, we've got 5 choose 1 or 5 combination 1. Then we've got 5 combination 2, 5 combination 3, 5 combination 4. So let me solve these ones using what we're just from talking about. Okay, so let's solve. So allow me to okay, it's fine. I need to erase the formula. So okay, allow me to write it here. So n combination r is just equals to n factorial over n minus r factorial, then r factorial. So how do we solve 5 combination 1? So this will be equals to 5 combination 1 will be equals to 5 factorial over 5 minus 1 factorial, then you have 1 factorial. So let's solve. So now on top I've got a 5 factorial, and so I'm going to have 5 factorial over 5 minus 1 in the bracket will just give me a 4 factorial multiplied by a 1 factorial. So now what are we going to have? 5 factorial can also be written as 5 multiplied by 4 factorial over 4 factorial 1 factorial. So the 4 factorial and the 4 factorial can divide, and I'm going to remain with 5 divided by 1 factorial. 1 factorial is just the same as 1, so the answer therefore will now be 5. So what general conclusion can we say? Any number combination 1 is always that number. Okay, any number combination 1 is itself. Okay, so what do I mean? If you've got 7 combination 1, it will give you 7. If you've got 9 combination 1, it will give you 9. Okay, so this is the rule that you're supposed to know. Then our next question is, we've got 5 combination 2. So how do we so we're going to have 5 combination 2 will be equals to, we're going to have 5 factorial over 5 minus 2, that is just a 3. So this is 3 factorial 2 factorial. Then what am I going to do on top? I'm going to say 5 multiplied by 4 multiplied by 3 factorial. I've ended at 3 factorial because there's a 3 factorial down. Okay, multiplied by 2 factorial. So the 3 factorial and the 3 factorial will cancel. 2 factorial is just the same as 2 times 1, which is just the same as 2. So 2 factorial into, or 2 into 2, that is just a 1. 2 into 4, that is a 2. Okay, then a 2 multiplied by the 5 that is there, I'm going to have a 2 multiplied by 5 that is there, I'm going to have a 10. Okay, now let's solve another one. We've got 5 combination 3. How are we going to solve this? So I'm going to say 5 combination 3 will be equals to 5 factorial over 5 minus 3, that is just a 2. So I have a 2 factorial 3 factorial. So I'm able to see that this one and this one, they're going to give me the same answer. So this will be equals to 10 as well. Okay, this will be equals to 10. Okay, let's solve the last one. The last one is 5 combination 4. So 5 combination 4 will be 5 factorial over 5 minus 1, that is just a 1. So I have a 1 factorial multiplied by 4 factorial. So I'm going to have 5 multiplied by 4 factorial over 1 factorial 4 factorial. The 4 factorial and the 4 factorial, they are going to divide. 1 factorial is just 1. 5 divided by 1, that is just a 5. So the last one is also giving us 5. Another rule that you are supposed to know: if you have a number, if let me say the number that is here is just followed by the number that is down, okay, or the difference between the two is just 1, so the number on top will always be the answer. What do I mean? If I've got 6 combination 5, the answer will be 6. If I've got 8 combination 7, the answer will be 8. Okay, if I've got 9 combination 8, the answer will be 9. Okay, so it is very important to also understand that part. Okay, now that we've known and we found the answers, let's replace where there are combinations to see what we are getting. Okay, so this is our expression. So let's write the answer. 2 to the power 5, that is a 32. So I'm going to have 32 here, plus 5 combination 1. We said any number combination 1, it is just that same number. So I'm going to write my 5 there. Then this 5 is multiplying by 2 to the 5 minus 1 on top, that is just a 4. Then 2 to the power 4, that is a 16. So allow me to write my 16 here. So 5 is multiplying by 16. Then I've got x. Then I come to the third term. 5 combination 2, we found that it was a 10. Okay, this 10 multiplied by 2 to the power 5 minus 2. 5 minus 2, that is a 3. 2 to the power 3, that is 8. Okay, so I'm going to have an 8 here. Then don't forget your x squared, it's multiplying by x squared there. Then we come to the other part, this one. So 5 combination 3, 5 combination 3 we found a 10 as well. Okay, so that was a 10. Then this is going to be multiplying by 2 to the power 5 minus 3. 5 minus 3, that is a 2. 2 to the power 2, that is a 4. Okay, so this will be a 4. Then don't forget your x to the power 3 at the far end. So plus, then 5 combination 4, we said if you've got the difference is only 1, okay, between the two, you're just going to get the number. So that combination is just giving us a 5. Then we've got 2 to the power 5 minus 4, that is just 5 minus 4, that is 1. Okay, so that's 2. So 5 is multiplying by 2. Then you have x to the power 4. So I'm going to put the x to the power 4 plus the last one is x to the power 5. Okay, then we simplify this expression. Okay, so what we are going to have, we're going to have our 32 plus 5 multiplied by 16, that is 80. So I have 80x plus 10 multiplied by 8, that will be 80. Then don't forget your x squared, plus I've got 10 multiplied by 4, that is a 40. Then don't forget your x to the power 3, plus I've got 5 multiplied by 2, that is a 10. Don't forget your x to the power 4 plus x to the power 5. You're also able to see that the powers of x are also increasing. So this is how you solve expansions using the binomial theorem.